Hello students, here we are going to state and prove De Morgan's law. Statement is already visible on the screen. A union B complement is equal to A complement intersection B complement. A intersection B complement equal to A complement union B complement. Definitely these two are set identities, and to prove these identities the right method is we show this left hand side is a subset of the right hand side and the right hand side is a subset of the left hand side. So we go for the proof of the first part. This is our beginning statement. Let X belongs to A union B complement. And you know the meaning of complement is when X belongs to A union B complement, it implies X does not belong to A union B. This is the very meaning of complement only. So this implies X does not belong to A and X does not belong to B. Here you may think कि usually with union or is associated. How come we are writing and in place of union? Let us look at the Venn diagram. This A union B, it means this shaded region. And when X does not belong to this shaded region, definitely X is neither in A nor in B. So that is why we are using the word and in place of X does not belong. Or you can remember in this way also, कि when X belongs to A union B, that means X belongs to A or X belong to B. But when X does not belong to A union B, that means X does not belong to A and X does not belong to B. This implies X belongs to A complement and X belongs to B complement. Why? It is the very definition of complement. If X is not there in A, certainly it will be there in A complement, and the same for B complement. Now it is a case of belongs to and the word is and. That means X is a common element of A complement and B complement, and we can write down it by A complement intersection B complement. So what do you experience here? I started X belongs to A union B complement and ended up with X belongs to A complement intersection B complement. Therefore, by definition of subset, A union B complement is a subset of A complement intersection B complement, and you can write equation number 1 for this. So far our approach is we have proved this left hand side is a subset of the right hand side. Now we will be proving this right hand side is also a subset of the left hand side. Then we can say the both the sets are equal. So here we go. This is our beginning. Y belongs to A complement intersection B complement. This is the very right hand side, and this implies Y belongs to A complement and Y belongs to B complement. And if Y belongs to A complement, definitely Y does not belong to A and Y does not belong to B. If Y is not there in A and B, that means Y does not belong to A union B, which implies Y will belong to A union B whole complement. So what do you see? Y belongs to A intersection A dash intersection B dash and Y belongs to A union B whole dash. Therefore, A complement intersection B complement is a subset of A union B whole complement. So you can put equation number 2 for it. So what we see? We got in number 1 कि this set is a subset of this in number 2, this set is a subset of this. Therefore, by equality of two sets, we can write down from 1 and 2, A union B whole complement equal to A complement intersection B complement. And this proves the first part of De Morgan's law. Now we do the second part. This is the left hand side of the second result. So we have assumed X belongs to A intersection B whole complement. What does it mean? X does not belong to A intersection B, which implies X does not belong to A or X does not belong to B. Again, the doubt may come कि usually with intersection and is associated. How come are we writing OR over here? Let us look at the Venn diagram. Here is our Venn diagram of A intersection B. This was A union B, this is A intersection B. This red shaded region represents A intersection B, and the situation is कि X does not belong to A intersection B. That means X can belong to this part or this part. So that is why in this case we use the word OR. Going ahead, what we see, if X does not belong to A and B, that means X will certainly belong to A complement or B complement. So this implies X belongs to A complement union B complement. So hence A intersection B whole complement is a subset of A complement union B complement. Now we prove the reverse way. That means this set is a subset of this set. Here is the reverse way. We took Y belonging to A complement intersect union B complement. That means since it is a case of belongs to, this union is replaced by OR. Since Y belongs to A complement and B complement, that means Y will not be certainly in the set A or B. And since OR is there and does not belong to, definitely we will go for intersection, and it is supported by the Venn diagram as we have seen. So this would imply Y belongs to A intersection B whole complement. What does it mean? A complement union B complement is a subset of A intersection B whole complement. And from 1 and 2, we can conclude A intersection B complement equal to A complement union B complement. So this is the complete proof of De Morgan's theorem, De Morgan's law, both way. One examination tip I am giving you: while proving this identity, one side you should do it carefully, and for the other side, this is from left to right, and when you have to go to right to left, you have to just reverse the steps. Like you can see, X belongs to A dash union B dash. Here Y belongs to A dash union B dash, and like it was coming in this way. The other proof may you have to go in a reverse way. So if you do in this way, then your proof is correct. I hope you understood. Thank you very much.